we will study some second order curves like ellipse, parabola, and hyperbola. Let us initially, I will show you some figures concerning how possible to receive these curves. Here you see two figures. In the first, here, this is like this. That means that here you see, just a moment, I will take my pen. You see here the cone, which is there is it is cut by some plane. This is a plane, and you see here appear this circle. That means because this plane perpendicular to axis of the cone. The second picture, when it is on oblique situation, this plane. In this case, in section appear this ellipse. The next two figures show us how it is appear other type of the curves. That means the same cone, but now this plane is parallel to the surface. That means the side of this bottom cone, and here appears a parabola. And if you take the oblique, that means which is should be cut this cone parallel to the axis. You see here appears the hyperbola. Therefore, it is very interesting to find the equations. Why it is then this curve, which is I showed you, called conic sections. That means conic curves. That let us initially consider the simple case when parabola. If you have the parabola, it is possible to make the following. That means here I have the coordinate system, Cartesian coordinate system. This is x directions, x, here the y, and here the line which is parallel to axis, and the distance pi. Because this is origin of coordinate system, therefore y coordinate of this line always should be equal to p. That means I will take some point which is it is lie on the y-axis and also in distance p. That means this distance and this distance equal to each other, but this is this point called the focus. This line called directrix. That means x coordinate of a directrix equal to minus pi. Y coordinate of directrix called equal to minus pi. That means we define the curve like this. That means this point on the curve should be equidistant from the focus and this line. That means this distance and this distance equal to each other. Therefore, I will write the equations. Should be possible to write the following equations. How to define the distance between the 2 points on x, y coordinate system. I remind you That means we have here the coordinate. That means which is defined at x1, y1, and other point x2, y2, y2. The distance between them, that is d, defined by the following equation. That means the d should be under root here x2 minus x1 square, possible to replace x1 and x2 because you take the square, therefore will be the same result, plus y2 minus y1 square. This is gives the distance between the point. Therefore, in this case, because here, that means this distance and distance equal to each other, coordinate of this point, that means the coordinate of this point on the curve, equal have the noted by P, has the coordinate x and y. This focus has the coordinate because it is a fixed. That means the x coordinate equal to 0. This is equal to P. This coordinate of the point, that means perpendicular to the directrix, equal to x, and minus, here's the y coordinate, minus pi. Therefore, I will write initially distance from this to this. That means that I will write the distance PF should be equal x square, because F point has the x coordinate equal to 0, and plus y minus P square, because the y coordinate equal to P. That means that now Q point, that means that distance to directrix should be equal to under root. Here's the x, because the x coordinate equal to the same, x minus x square, plus, because here's a minus pi square, should be pi square. That means we equaling this. So this distance, because according definition of the parabola, it is that means a parabola, it's set of the point of the curve, so that it is a point should be in equidistant distance from the focus and directrix. That means the PF should be equal to PQ. That means the equaling to taking the square and make some manipulation, you receive following equations. That means you receive the following equation. That means the y should be equal to x squared divided to 4 p. This is follows from this equality. I will omit that means you can't manipulate yourself. That means when you take the square, and then you will find it is not difficult. That means here's a p larger than 0. This, you see, this is defined as a parabola. That means possible to define the other type of parabola. In this case, parabola has the following form. You see, that means this parabola, like this. That means it is go to up. That means this is a concavity up. Now, that means this is should be written as y equal to x squared divided 4 pi. That other parabola, that means when we have which is a downward direction. If the downward directions, that means here the x or from origin. That means this curve should be equal to y equal to minus x squared divided by 4. That means that we have these two parameters, type of parabola. The other parabola possible to construct by other thing. That means that in these figures you see first case, this is the second case. Here, that means the directrix now parallel to y-axis and focus in the x-axis. That means this distance equal to this distance. In this case, again, equaling the distance from the fork to calf, and this distance from this point to directrix. Again, that means after some simplification, if the distance here there will be a p, here distance p, because this now coordinate will be, or x coordinate will be negative. That means you see x equal to minus pi, p. You receive these equations. That means for this case, I receive the following curve. That means that for first case, I receive, that means that this curve, parabola, here's the x, here, here's the y, here's the x, and yes, come.
It is not visible. Put it like in front of the camera.
In front of the camera.
Yes,
Okay.
You are holding like towards this side.
Okay. I will go to camera, right?
Yes, sir.
Okay. That means that means again you see to this picture. That means that here they shown when focus now place it on x-axis, directrix parallel to y-axis. That means that this distance equal to p, and this distance also equal to p. If you take any point here and you take the distance to directrix and the distance to focus, they should be equal to each other. After that means equaling this distance, you receive this curve, which equation will be equal to y squared equal to p 4 pi x. Other case should be this case. That means that now I will take again, but directrix here was from the left side, and this is was the right side, focus from right side respect to y-axis. Now will be reverse. That means that here will be focus. This is y-axis. This is x-axis. That means that here will be. That means that we will take focus. Here take directrix. In this case, equaling again the distance from the point to directrix and to focus, I receive these equations. That means that we receive the following equations. That means should be like this parabola, and equations y square should be equal to 4 pi 4 pi x. That means possible we have the 4 type of parabola. This parabola and this parabola. It is depend how it is we took position of focus and direction of directrix. That means this is a first curve which is possible to get from conic sections. The second, let us now, I will consider other type of the curve. which is we called ellipse. That means for this case will be not one focus, should be two focus. That means this is a focus 1, which is noted by letter F1. Coordinate of this has a minus c. That means this is a distance equal to c, but because it is from the left side of the y-axis, therefore this has a negative coordinate. And y coordinate equal to 0. The second, it has second focus. That means in right side, its coordinate, the distance the same like this, but coordinate should be positive. That means it is noted by F2. F2, that means there will be C x coordinate and y coordinate also 0. That means the definition of the ellipse, it is the following. That means it is a set of points on the curve when the sum of the distance from the point on the curve to the focuses, the sum, that means this distance plus this distance, should be constant. That means now I will write this equation for second curve, which is the ellipse. That means again that here's a focus F2, here's a focus F1. Coordinates C0, coordinate minus C0. And here's some points. That means some point. Here's a P, which has coordinate x, y. That means that this distance and this distance should be, let us to write what will be this distance. That means PF1 should be under root x minus, you see, minus c, therefore should be plus c square plus y square. F2 should be equal under root x minus c square, y coordinate of this 0, therefore will be y2. That means that here that the sum PF1 plus PF2 should be constant. This constant I will take equal to A. I will explain why it is better to take to A, not any constant A, but I will take the 2 doublet. Because this curve, if you plot this graph, you receive the following curve. It is not so. Okay, that means this curve. This curve, you see? That means because the distance should be for any point. I will take this point. If I will take this, will be this point. The distance now from the fork equal to this. Distance from the second fork equal to this one. That means I must add. That means that it is necessary to have the add. If for this distance I will add, it is the same if I add this distance. But that means that this distance from this vertex, it is called vertex 1, this will be equal to vertex 2. That means the distance from the vertex 1 plus to vertex 2 exactly, that means the v1, v2 exactly equal to 2a. So again, equaling, that means make the equaling this one to each other. That means you receive following equation: x plus c square plus y square should be equal to plus under root x minus c square plus y square should be equal to 2a. Again, this term you take the right side, then take the square from both sides, then simplify. Again, you will take the square, and you get the following equations. That means there will be x square divided to a square should be equal. This distance, I will take this distance. That means this distance, because you see the distance c. That means this is a c. Therefore, this will be y square. Here will be a square minus c square. A minus c square. So that means plus equal to 1. You receive from this equality, you receive this equation after simplifications. This is the standard equation for ellipse. That means now I note a, because you see a this distance. That means the distance from the origin, this is origin, to vertex. That means therefore a square larger than b c square. C is the distance to focus. That means now if I note the b square equal to a square minus c square, which is larger than 0, we receive the equations. We receive the equations x square divided to a square plus y square divided to b square equal to 1. This is the standard equations in Cartesian coordinate for ellipse. Let us now, what meaning of A? That meaning of A, it is distance between the vertex, or distance from origin to vertex. Because the distance, this distance and this distance should be the same. Therefore, A is called is a semi-major axis. What does that mean? That means it is a half of distance between them equal to hold the semi-major axis. What's the B? B should be half of this distance. That means this distance will be B. That means the B is called the semi-minor axis. Axis. That now let us consider now the position of the foci. Here possible the foci. That means the foci have the following coordinate, because this and this is a coordinate x coordinate negative. Here's a x coordinate positive, y coordinate both has the 0. That means that here we have the following plus minus c 0. That means vertices. Vertices coordinate, that means the distance, this is a distance a, this is distance a, but because here in the right side, that means this is therefore will be equal to c, that means a, here will be minus a, x coordinate. That means that means equal to plus minus a and 0. That means the main equation, this one, but you must take into account that a always larger than b. Okay, let us now we consider other type of curve when the focus is placed not on the x-axis, but in the y-axis. That means we have again x-y coordinates axis. This is the x, this is the y. That means here this will be f 2. I will take the f1. That means the other. That means here's the f2. The coordinate of f1. That means the coordinate will be equal to x coordinate. You see equal to 0. That is from right side I will write. That means that here's the f1. That means that has the coordinate c 0 because and c. f2 has the coordinate 0 and minus c. That again, if I will take the same procedure, that means the distance from the fork to point of the curve should be the sum of the distance from the focus to the curve should be equal to a. I receive this type of the curve. That means that here is a vertex 1, here will be vertex 2. That means this will be now, this will be distance equal to a, the distance equal to a, but coordinate should be equal to what? 0 and a. Here coordinate will be 0 and minus a. Minus a. That means if you take the distance, that means that, for example, this is a point P, which is x, y. That means this sum of this distance and sum of this distance should be constant. Constant, and we receive following equation. That means that x squared divided to b squared plus y squared divided to a squared equal to 1. That means again a larger than b, where b square equal to a square minus c square, like in this case. But now you see is a change. Compare this equation and these equations. So that means that we receive this coordinate. And at last, let us we consider other type of curves. Hyperbola. How we define the hyperbola? That means again you can see this figure. Here also there is a two foci. That means the focus one here, focus one here. This is on x-axis. Y-axis, has this direction. It is not shown. This is y. That means the origin of the xy coordinate, center. That this point called the vertex. That means that now we will take not the sum between the foci to the points. We take the difference. That means that we take the difference. Now, that means now I will take the following. That means the letters I will plot this graph. That means here foci should be here. That means this is F1. And here's the center. This center, O. That means this coordinate system X. Here's a Y coordinate, Y. Foci distance from the origin to first foci into second foci, the same. That means that here's a F2. That means that again the distance from origin to foci we noted should be equal to C. That means the coordinate will be C, Y coordinate equal to 0, or minus C. That means that here will be minus C, minus C, 0, and here will be C, 0. And here there is some, that means that we will take some points. That means that here I will take now I plot the parabola, this one, that means the other parabola, oh sorry, hyperbola should be the following. That distance, here's a P, X, Y. I will take the point, or possible to take the point in this curve, or in this case, it doesn't matter, the result will be the same. That means that I will take the distance, this one, and distance to this. That means that now distance P, F1 minus distance P, F2 should be equal to constant. This distance we will take to A. That means let us here I will take the sum axis, which is parallel to y-axis. This axis should be equal to, because it is perpendicular to the axis, and this distance to vertex I will take equal to x should be equal to minus A. X should be equal to minus A. Here the other side curves, which is parallel, that X here should be equal to A. You see, if I will take this is a vertex, this is the vertex of the of this side of parabola hyperbola. This is the other side. That means now that means from, because subtraction of this from this distance always should be constant. Let us, I will take here the point in this point. You see? That means in this case the distance from F to this point will and it is necessary to subtract this. That means that because this distance and this distance the same, exactly if you take this distance, it will be equal to this one. Distance between the vertex. Between the vertex. Therefore, you receive what? It will be here the minus a, here the a. That means the distance will be exactly to a. Therefore, taken again to a. That means let us to write now the what will be PF1. PF1 will be under root x square x plus c square plus here's a y square, because this point y coordinate equal to 0. PF2 should be under root x minus c square plus y square also, because this has 0. Now, that means that we receive from this distance, I must subtract this distance. That means that under root x plus c square plus y square minus under root x minus c square plus y square equal to a. Again, to make the same manipulation as the for case of the same like for a case when you have for ellipse, you receive the following equation: x square divided to a square minus y square divided, here's a c square minus a square, plus a square, sorry, c square plus a square equal to 1. Note, if I will note the b square equal to c square plus a square, we receive c square divided to a square plus a minus y square divided to b square. That means this you receive these equations. That let us now. That means possible to receive other type of the curves. That means this is like this. Only in this case is changed. That means possible to get the following cases: 4 key here, F1, 4 key here, F2. That means in this case you receive like these curves. This is a vertex. That the distance should be to a. But in this case, equation should be the following: x square divided to b square minus y square divided to x square to a square equal to 1. This equation you receive. Well, let us. That means this, why it is called the second order curves? Because if you have the following equations, which is the second order, that means the x and y have the power 2. That means like this. That means the a11 x square plus a12 a12 x y plus a22 here's the y square plus b 1x plus b 2y plus c equal to 0. You see, here that means that this is a power of x second. Y here also should be second because it's a power 1. Here's a power 1. This is has the possible to set to 2. This is a 2. That means this is general equation for this of type, this parabola, ellipse, this describe parabola f. It is depend on these coefficients. The value of the coefficients, if you take, find such coordinate system where it is possible to reduce to this standard form of this equation, which I actually wrote. Therefore, this is general equation for all these type of the equation, and it is jointed under one consideration: parabola, ellipse, and hyperbola. But more simple equations for this type of the conics, that means the conics, I mean this parabola, ellipse, and hyperbola, has if you apply the polar coordinates. That means I will consider the polar coordinates that initially I will take some show you what will be directrix for parabola I showed you. Also we see only for directrix for ellipse. Directrix for ellipse and directrix for hyperbola. That means again for parabola. That means here's a y-axis. Here x-axis. Here's a parabola has a 1 fork. That means a C0 possible to write. That means this curve should be have the following form, like this parabola. That means the directrix should be in the same distance than fork. But directrix, it is a line which is perpendicular to y-axis. But if the fork will be in the y-axis, in this case, it will be parallel to directrix to x-axis. That means this is directrix. That means x equal to minus c. This is for that means for this case, when parabola. That means a parabola. First conic. Second, for ellipse. X, y. That means here we have following situation. That means here like this. Here's a forky 1, F1, which has the coordinate minus C0. Here's a forky 2, F2, C focus C0. And here's a B, here's a A, and that means the directrix. Directrix should be from this side. That means the directrix. Directrix, that means x equal to minus a by epsilon. I will define what means epsilon. That means here also directrix, second directrix, x equal to a by epsilon. Epsilon called eccentricity. Eccentricity E. Eccentricity we define by following formula. That means here that this is a C. That means eccentricity equal to C divided to A. Or possible to give the other for a definition. Directress equal to that means this ratio of the distance between the vertex to distance to foci. It is reduced to the same equations. That means this A. Because you see, that means that means E should be less than 1, but larger than 0. Very interesting, the following, that when the foci coincide, that means that if they coincide, that means it will be in origin. You receive the following result in this case. That means your ellipse generated and appear instead the ellipse appear circle. Here, the circle, that means eccentricity equal to 0. Equal to 0. And at last, for this case, I will not plot the graph. I will use the same. Now I will find what will be directress. That means the directress, or it is, no, it is better to plot new one. XY. Here's the directress. Number 1. Here's the directress number 2. It's the same distance from y-axis. Directrix number 2. The coordinate should be equal to x. Here's a equal to eccentricity. Eccentricity, I told this is definition of the same as the like the polar. That means for ellipse. That means the eccentricity is the ratio of from C to A. That means A divided to epsilon E. That means here will be x equal to minus A divided to E. So that means what will be graph in this case? That means here's a foci F1, here's a foci F2. That means we have following this, and here the other. That means the distance, this is distance between the F1, F2, it is a 2C. That means half, this will be c, c distance. That means a, it is the distance between the, here. That means if I will take the, here distance for through A, that means if A, it is the distance from origin to here, this is, will be A. That means vertex, here's a vertex 1, vertex 2, here's a vertex 1. Here's a vertex 1. That means this distance 2A. 2A. That, that this distance will be A divided to epsilon, this one. Because you see, now the C, here's a larger. The 2C larger than 2A, because the distance between the vertex smaller than distance between the this one. So applying this all these pictures again to take this coordinate, that means the distance, difference distance from this point to this point. If you from this you subtract this one, should be 2A. We receive the equations. A square minus yb square. For this case, we receive x square to a square minus y square divided to b square, where b square equal to a square plus c square, to c square. That means you can find the distance from the A. That means it is much easier if you apply following conic coordinate. Because here the center was in the center origin of Cartesian coordinates should be here, where is the crossing of the point. But sometimes it's better to find the equation in the polar coordinate, to take the origin for polar coordinates, origin, in foci, or in one of the foci. Let us, I will show you what will be in this shape. Oculus. That means that I will take here foci. This is the focus, F, sum of the focus. It doesn't matter what type of the curves. It is parabola, ellipse, or hyperbola. That means in this case we have the following curves, like this. Right? Here's because the origin I will take here. This is F. That means this will be R. And here's the initial ray. That means here's the X. And here the directrix. Directrix X equal to K. Because this distance, that means from origin, this one, this is a K distance. That means this has a coordinate K. This, from this right angle triangle, that means that this will be R cos, R, that means that here this will be R cos theta, because angle here is a theta. R cos theta, this is point P, therefore possible to find the coordinate P, and that means R cos theta. So using all this manipulation in the your book, you will consider, that means this is some type of the conical section, that means parabola or hyperbola, you receive the equations. That means the PF, here's F, PF should be equal to R. And PD, this is this distance, that means this distance, D, PD equal to K minus FB. if I note this point B, this point, I will note the B, this point B. K minus FB, FB, which is possible to write as the K minus cos theta, R cos theta, sorry, R cos theta. And that means that R equal to E. From here you receive E. Here will be K minus R cos theta. So after simplifications, using what the value, that means R, from solving this one, R possible to write that R equal to, here you insert A to A, to A R to K minus R. That means that here will be E, not necessary this one. It is extra. That means that after that you reduce these equations. The following: R should be equal to K E divided 1 plus E eccentricity cos theta. This is general equation for this parabola, ellipse, and hyperbola. That means the K larger than 0. That means here only for parabola and ellipse it is necessary to find this distance K. It is depend on from here you will find, or from ellipse or parabola. For parabola, K equal, that means E should be E should be 1. That's all for today. Well, the previous times we considered some solutions of application of these equations.